In this video lecture, I will discuss the method of variation of parameters. So we would like to solve non-homogeneous second-order linear equations of the form a y double prime plus by prime plus cy equal to g of x, where a, b, c are constant, and usually g of x is a function of x. So in the previous topic, we learned the method of undetermined coefficients. We make a guess for capital Y and then we solve. Unfortunately, for some equations, we won't be able to guess the correct format of capital Y, and so we need a different method. And variation of parameter is one of the two methods we will learn. So let me recall that the general solution to the above non-homogeneous equation has the following form: y equal to c1 y1 plus c2 y2 plus capital Y of x, where y1 y2 form a basis for the solutions to the corresponding homogeneous equations: a y double prime plus b y prime plus cy equals 0. So to see what's the difficulties with the previous method that we learned and how we use a new method to solve, let's look at an example. So example 1, solve the ODE. Y double prime plus y equal to secant of x. So as usual, we have our non-homogeneous equation. So we begin by solving for y1, y2 from the corresponding homogeneous equation. So our corresponding homogeneous equation is y double prime plus y equals 0. We have the characteristic equation. R squared, and be careful here, there's no y prime, so no r. Just y here will give us just 1. And solving this, we have r squared equal to -1, and we need to take square root. So plus or minus square root of -1, and we have plus or minus I. Having complex root, the two solutions, y1 and y2, involve cosine and sine. So y1 is plus or minus I is actually 0, plus or minus 1 times I. If we want to rewrite in the format of alpha plus or minus beta I here. So because alpha is 0, there's no exponential. We only have sine, cosine. And cosine of beta is 1. So cosine of 1x. And the second one is sine of 1x. Now, recall that our right-hand side, g of x, is secant of x. What is a guess for capital Y of x? Well, first of all, we haven't seen such a thing before in the previous topic. Right? In the previous topic, we saw sine and cosine. Then we guess capital Y to be A times sine plus B cosine. But here secant. Well, you may think of trying, say capital Y x equal to A secant x. But it turns out not. This guess will not work. And the reason is, if you take derivative, the derivatives are getting more complicated. So a derivative secant is secant tangent. And if we take derivative one more time, then well, we need to use the product rule, and it will be complicated. Okay, so when we plug in, we try to get secant of x on the right hand side, it won't work. And in fact, later on, when we get the final answer, you would definitely say that it's impossible to guess the correct format for capital Y. So instead, we're gonna use a different method, so-called the method of variation of parameters. So this method will give us the general solution as well. So in fact, we don't go through the separate step of finding capital Y. It will give us the general solution. So from the general solution, we'll have the format C1 Y1 plus C2 Y2 plus something, and that thing would be capital Y. So how do we do that? We look for general solution of the form y equals to u1 times y1 plus u2 times y2, where u1, u2 are two unknown functions. That we need to determine. So we are introducing two new unknowns. You may say, well, it's much more complicated, right? Because we introduced two new unknowns. But it turns out that the method will work, two new functions. This format right here, u1 times y1 plus u2 times y2, resembles c1 y1 plus c2 y2. But instead of constant c1, c2, we're looking at functions u1 and u2. And that's why the name variation of parameters. The c1 and y1 are constant, are called parameters. But now they're not constant anymore. We variate them to functions u1, u2. And that's why the name variation of parameters. Okay. Now, keeping in mind that we will have, what is y1? We solve y1 cosine of x, and then y2, so u2 times sine of x. Let's take derivative. And because u1 and u2 are functions, we need to use product rule here. We will have u1 prime cosine x, and then plus u1 times derivative cosine, which is negative side of x, and then plus u2 prime sine x plus u2 times cosine of x. Now, because we have two new unknowns, u1 and u2, we need to create two equations for u1 and u2 for us to solve. So it turns out that the first equation we need to do is as follows. First, we will make y prime into two groups. The first group contains the derivative of u, so u1 prime, u2 prime. I will combine them into this u1 prime cosine x plus u2 prime sine of x, my first group. And the second group, I just leave the rest, so minus u1 sine x plus u2 cosine x. Now from here, we create the first equation by setting the whole group here to be 0. u1 prime cosine x plus u2 prime sine of x equals 0. This is our equation 1 that involves u1 prime and u2 prime. We will use it later. So after creating this equation, we simplify y prime. Because the first group is already 0, here is 0, so y prime just has two factors, two terms left at the end here. So minus u1 sine x plus u2 cosine x. So it's very important in the method of variation parameter is that we create our first equation exactly in this format. We use the u1 derivative and u2 derivative to make equation 1, and also at the same time to simplify y prime to just two terms instead of 4 like originally we have here. Now continue taking the derivative double prime. We use the product rule again. So minus u1 prime sine x and then minus u1 cosine x plus u2 prime cosine x, and the derivative of cosine is negative side, so we have minus u2 times sine of x. Now plug into our non-homogeneous equation. Non-homogeneous equation says that y double prime plus y equal to secant of x. And y double prime has 4 terms above, so let's use them. Minus u1 prime sine of x minus u1 cosine x plus u2 prime cosine x minus u2 sine x. It's a little bit long here. Plus y. Y is what? Let's go back to y. Y is u1 cosine x plus u2 sine x. So over here we have u1 cosine x plus u2 sine of x. And on the right hand side we have secant of x. Now simplify things. We will collect like terms. Cancel things. Here minus, we have minus u1 cosine. This is plus, cancel. Minus u2 sine plus u2 sine, cancel. So it turns out that the terms without the derivative cancel out. And what we have left is just term with derivative u1 prime psi of x plus u2 prime cosine of x equal to secant x. This is our equation 2. So, to create equation 2, we need to plug in the non-homogeneous equation, cancel terms. And in general, it works this way. All the terms without derivative would cancel out. Only the term with derivative left here. So let me recall the first equation right here. u1 prime cosine x, u1 prime cosine x plus u2 prime sine x equals 0. That's the first equation. Now we have two equations with two unknown, u1 prime, u2 prime, so we might try to solve. So these equations are more difficult than solving a system of linear equation. But we do the same thing. We will try to do the method of cancellation. So in order to cancel, say, u1 prime, I'm gonna multiply equation 2 by cosine. So equation 2, and I multiply everything by cosine x. Then I will have minus u1 prime sine x cosine x plus u2 prime cosine x and another cosine x equal to secant x cosine x. And for equation 2, I will multiply by sine of x. Then I would have u1 prime cosine x sine x plus u2 prime sine x, another sine x equal to 0. So this is equation 1 right here, and we need to multiply everything by sine x. And that's what we get down here. Now the reason I have done what I'm doing, this is equation 1, not 2. The reason that I have done is to create opposite terms here, and then I can add them up, the two equations. So the first two terms cancel out, and I have left u2 prime cosine squared plus u2 prime sine squared x equal to secant times cosine. What is secant times cosine? Secant is 1 over cosine. So basically we have 1 over cosine times cosine. Now u2 prime is a common factor we can factor out, and we have cosine square x plus sine square x left there, and the right hand side just 1. But also, what is cosine squared plus sine squared? Our familiar Pythagorean identity, which gives us 1. So what we have left is u2 prime equal to 1. So we have made some progress here. We have solved for u2 prime. Now we need to find u1 prime. Substitute into equation 1. After solving for u2 prime, you may substitute in either equation 1 or 2, but I would recommend equation 1 because that equation is easier. If you go back here, equation 1, the right hand side is 0, so much easier. Now we substitute u2 prime equal to 1 into here. Then we will have u1 prime times cosine x plus 2 times sin x. Cosine x, sorry, plus u2 prime, which is 1 times sin x equals 0. So we solve for u1 prime is minus sin x over cosine x, which is minus tangent of x. So far we have solved for derivative u1 prime and u2 prime. In order to get u1 and u2, we need to integrate. u1 would be the integral of minus tangent x dx. Now what is the integral of tangent? This is one of the formula you should remember. That's integral of tangent is log of absolute value of secant. So we'll have minus log of absolute value of secant x. And don't forget plus constant c. This would be c1 because we are integrating for u1. Similarly, u2 will be the integral, but this is easy because u2 prime is 1. So 1 dx. And we get x plus c2. Now knowing c1 and u1 and u2, we put everything together. Then we have y equal to u1 times cosine x plus u2 times sin x. This is what we started with. And so u1 is minus log of absolute value of secant x plus c2 everything times cosine x, and u2 is x plus c. This is 1 x plus c2 sin x. Now let's distribute it. We want to rewrite the solution in the correct format. c1 y1 plus c2 y2 plus capital Y. So let's distribute in and rewrite in that order. So we will have c1 cosine x plus c2 sin x. And what left would be minus, let me write, we distribute this cosine in. And let me write cosine first, so cosine x, natural log of absolute value of secant x. And then I also have x sin x there. So from this solution, we see that we have c1 y1. This is that piece. And then right here is c2 y2. So whatever left, the whole thing here, is our capital Yx. So Yx is minus cosine x log secant of x plus x sin x. And you can see that there's no way we can guess for capital Yx at the very beginning. So the usefulness of the variation of parameters is that it helps us solve the equation without guessing for capital Y, because we don't know what the correct guess is. However, it's a little bit lengthy. Now to understand more of the method here, let's look at another example. Example 2. Solve the ODE. Y double prime minus y prime minus 2y equals to 18x e to the 2x. As before, we begin by solving for y1, y2 from the homogeneous equation y double prime plus y prime minus 2y equals 0. And so we have the characteristics equation. R squared minus r minus 2 equals 0. Solving this, we are by factoring or by quadratic formula, we will have r1 is -1 and r2 is 2. We have two distinct real roots. So y1 is e to the negative x and y2 is e to the 2x. Now, for this problem, our gx is a constant times x e to the 2x. So 18 times x e to 2x. It's actually possible to have a correct guess for capital Y and solve for capital Y. Okay, it's possible to do so. However, in this example, we'll focus on variation of parameters. So we're going to use that. So let me just write that it's possible to use the method of undetermined coefficients. But we'll try variation of parameters. So for variation of parameters, we look for general solution as well. Y equals to u1 times y1 plus u2 times y2, where u1 and u2 are two functions, not constant. So we have u1 times y1 above is e to the negative x plus u2 y2 above is e to the 2x. Now in the solutions that I provide on Blackboard, I use v1 and v2. Doesn't matter. Okay, you might use v1, v2 or u1, u2. As long as we know that those two are functions, that's okay. Now we take derivative using the product rule again. We will have u1 prime e to the negative x, and take derivative of e to the negative x, we have minus sign. So minus u1 e to the minus x plus u2 prime e to the 2x plus 2u2 e to the 2x. And then we create our first equation. By grouping the terms with derivative and setting that equals 0. So u1 prime e to the negative x plus u2 prime e to the 2x, and I set this equals 0. This is equation 1. And at the same time, simplifying y prime. because we have grouped the two terms together and set the sum equals 0, we only left with minus u1 e to the negative x plus 2u2 e to 2x in the derivative. Now take derivative one more time, second derivative, so minus u1 prime e to the minus x plus u1 e to the minus x plus 2 u2 prime e to the 2x plus 4 u2 e to the 2x. And now we need to plug into non-homogeneous equation. We have our second derivative as above, so rewrite it minus u1 prime e to the minus x plus u1 e to the minus x plus 2 u2 prime e to the 2x plus 4 u2 e to the 2x minus derivative y prime, which is here. So minus u1 e to the minus x plus 2u2 e to the 2x. And lastly, we need to minus twice of y, which is u1 again e to the minus x plus u2 e to the 2x. The right hand side for the non-homogeneous part, we have 18x e to the 2x. Now we need to distribute and cancel like terms. But as before, we need to check, but as before, all the terms will cancel out except the term with derivative, which are here. So we rewrite those terms with derivative minus u1 prime e to the minus x plus 2 u2 prime e to 2x. But let's check here. If we simplify u1 e to the minus x, then here we have 1 times u1 e to the minus x. Distributing here, we will have plus u1 e to the minus x. But here, when we distribute in, we have negative 2 u1 e to the negative x. So they cancel out. Similarly, this is 4 u2 e to 2x. And then we distribute, we have negative 2 u2 e to 2x. And this is another negative 2 u2 e to 2x. So they all cancel out. Only the derivative is left. We have 18x e to the 2x. This is our equation 2. Let me rewrite equation 1, which is here. u1 prime e to the negative x plus u2 prime e to the 2x equals 0. That's what equation 1 is. So we solve for u1 prime and u2 prime by the method of elimination. And in fact, in this case, easy to see what we should do. I would add this equation up. Then the first two terms cancel out. And then we just have 3 u2 prime e to the 2x equals to 18x e to the 2x. And we solve for u2 prime. Divide both sides by 3 and then e to 2x. We get u2 prime is 6x. Now plug into, as before, equation 1 to solve for u1 prime. We have u1 prime e to the negative x plus u2 prime, which is 6x e to the 2x equals 0. So then u1 prime e to the negative x equal to minus 6x e to the 2x. u1 prime multiply both sides by e to the x, then we'll get e to minus 6x e to the 3x. This is u1 prime. Now the next step is to integrate. We know that u1 prime is above, so u1 is the integral of minus 6x e to the 3x dx, and we need to use integration by parts. I will leave it for you to do integration by parts, but over here I'm gonna just write down the answer. We get minus 2x e to the 3x plus 2/3 e to the 3x plus c1. And similarly, u2 is the integral of, let's go back here, u2 is 6x. So we have integral of 6x dx, which is 3x squared plus c2. Now put everything together. We have our y is u1, which is the long expression above, minus 2x e to 3x plus 2/3 e to the 3x plus c1 times e to the negative x. Like what it is u1 times e to the negative x plus u2 3x squared plus c2 times e to the 2x. And now we need to distribute in to rewrite in the correct format. So first we distribute, we have c1 e to the negative x, and then c2 e to the 2x, plus what left here, distribute the negative x in, and cancel things. We have minus 2x e to the 3x times e to the negative x give us e 2x. And similarly over here we have 2/3 e to the 3x times e to the negative x to get e to 2x plus 3x squared e to the 2x. So this is c1 y1, this is c2 y2, and whatever left is our capital Yx. So as I mentioned earlier, it's possible in this problem to guess for capital Yx, but we chose to use a different method, variation of parameters, to solve the general solution. And this is the end of this video lecture.